presentation. So I appreciate the committee's efforts in bringing this together. I think this will be an interesting discussion. Hopefully this will generate future discussions as well. So Mary, I'll turn it over to you.
Thank you very much. For those of you who don't know, Keith is retiring, so we're going to be without his wise counsel going forward. And we thank you very much for stepping in and chairing our council and on all of your guidance over the past year. It's been a good ride for everybody. So best wishes in the future. With no further ado, we have some very esteemed panelists here with us today. I'm not going to spend your time doing an introduction of all of them. They're going to introduce themselves as they speak, and they know that they've already decided the order they're going to speak within. We'll start with Chip Fletcher, please. Chip.
Hello, happy midday to all of you. I want to put a link to an opinion piece I published last week in The Hill for everybody in the chat, and it's not happening. I'll get to that a little bit later. My name is Chip Fletcher. I am Associate Dean for Academic Affairs at the School of Ocean and Earth Science and Technology at UH Manoa. And along with a group of absolutely brilliant graduate students and technicians over the last couple of decades, we've spent our time learning how beaches operate and attempting to both model and more deeply understand how they are going to respond to sea level rise in the context of community assets, especially. So allow me to get started here. I will share my screen and get us going. The title of today's symposium is Climate Change, Sea Level Rise, Shoreline Protection, and Erosion Prevention. And I want to spend a few minutes at the end of my talk talking about these terms in red: shoreline protection and erosion prevention. These are standard terms in government and in dealing with the problems of shoreline change. And I want to point out how they lead us into they lead us down a path of thinking that is actually not in keeping with protecting the public trust. But let's begin with what we know about global warming. This is the record of annual average temperature relative to the mean temperature between 1880 and 1900. This data set is from NASA, and 2020 came in last year, tying 2016 as the warmest year on record, and the two of them are just a few tenths of a degree short of 1.3 degrees Celsius warmer than the pre-industrial period. Now, 1.3 C is a useful benchmark to keep in mind because all of the nations of the world have pledged through the United Nations Framework Convention on Climate Change to stop global warming at 2 degrees C and to make extraordinary efforts to stop it at 1.5 degrees C. And a report came out in 2018 from the Intergovernmental Panel on Climate Change called the 1.5 report, which illustrates what the world will be like when global average temperature is 1.5 degrees Celsius above the pre-industrial average. And that report was filled with lots of information that indicated it would be a very unsafe world, both for natural ecosystems as well as for human communities. And since that report the effort at the United Nations and indeed among all the world's nations has been to cut greenhouse gas emissions in order to stop global warming at 1.5 degrees C. And as you can see here, we are very, very close to reaching that temperature. In fact, many projections have us reaching 1.5 degrees C and then rising above it by the end of this decade. The 6 warmest years in this 150-year record are all the past 6 years, and the 10 warmest years are all in the past 2 decades. Since 1970, you can see this blue dashed line. This is a linear trend that global warming has been following at about 0.18 degrees Celsius warming per decade. However, in the past 6 years, as you can see in the red circle, average annual temperature has now departed from this trend. And this indicates that the rate of global warming is accelerating. I want to begin with a few statements. One is that sea level has risen 8 inches since the 19th century. And look at the background photo. Only 8 inches of sea level rise, and we see very dramatic impacts on our communities. And this is Sunset Beach about a year ago at the end of summer, I believe it was, August, September timeframe. Everything we know about future sea level rise tells us that it will be many feet higher, rising much faster, and is essentially unstoppable for centuries. Though if we cut our greenhouse gas emissions and we manage to stabilize global warming, sea level rise can also be slowed and limited. And I'll show you why it's essentially unstoppable on a human time frame in a second. And this quote from Michael Oppenheimer, who was the lead author of the last IPCC report, which was in 2019, focusing on sea level rise. There is no scenario that stops sea level rise this century. We've got to deal with this indefinitely. So here, in an image that speaks 1,000 words, is what global warming looks like. This is temperature change relative to the global average. And you can see that the oceans are cooler than the global average. And for centuries, in fact, the models indicate that for millennia, the oceans will be absorbing heat from the air and thermally expanding as they attempt to get into equilibrium with that warmer air. That's why sea level rise is essentially unstoppable, because they're already out of equilibrium with the air temperature. And through vertical circulation in the ocean, those warm air temperatures, which translate into warm surface waters, then need to translate into warm bottom waters. And many of those lower layers are many centuries old. So it will take many centuries, in fact, over 1,000 years before the full temperature of the ocean represents the full temperature of the atmosphere. And we continue to dump greenhouse gas into the atmosphere, and we continue to drive global warming, which is accelerating. So this process of equilibrating the ocean to the air has not really had a chance to act in a serious manner. What you can see from this image is that continents are warming much faster than oceans. And this puts bread baskets, our main food production centers, and communities at risk, because those are all located on these rapidly warming continents. And most of the continental land mass is in the Northern Hemisphere. And it's in the Northern Hemisphere summers that climate scientists pay very close attention to heat waves, especially with regard to our bread baskets. Because the continents are warming so quickly is one reason I am happy to be located in the middle of the Pacific Ocean. I think that oceanic islands are one place to be where you can avoid the very worst in terms of the heat waves. Notice also that the Arctic is warming much faster than the global average. In fact, it's warming between 2 and 3 times faster than the global average. This is because it's losing sea ice, exposing dark ocean, Arctic Ocean surface, which absorbs sunlight, releases heat. And so the Arctic is warming very quickly. It is the planet's refrigeration system. The sea ice in the Arctic Ocean reflects sunlight. And as we lose that bright surface, the ability to cool the entire planet is also being lost. Greenland is in the Arctic, and as it experiences melting from Arctic amplification, it is forming a layer of volcanic ash and wildfire ash that is not being swept away by meltwater. It's accumulating as a lag deposit, making the Greenland ice sheet darker and darker. And in fact, the breakdown of these ashes provides nutrients for bacteria to grow on the ice, which themselves are dark. And so Greenland is experiencing less and less reflection, more and more absorption of sunlight, which is accelerating its melting. All that meltwater streaming off of Greenland makes the North Atlantic today the coldest it has been since it was first measured by Ben Franklin, sailing back and forth between Europe and New England. And that cold water has slowed an important circulation system called the conveyor belt, which pulls heat out of the Indian Ocean, out of the Southern Atlantic, and up into the North Atlantic, and normally distributes that heat across Europe, keeping the Northern European nations much warmer than they would be otherwise. But this global conveyor belt circulation has slowed as much as 15%. And so there's less warm water going through the South Atlantic. That means there's less evaporation off of that warm water, and we are seeing drought hit the Amazon and Congo rainforests. We also are leaving heat, warm water in the Southern Ocean near Antarctica, and you can see these red areas. That means that this warm water in the Southern Ocean is leading to accelerated melting in the Antarctic. And in fact, that warm water, significant parts of it are down around 500 meters depth, and they are causing the melting of floating ice shelves from underneath, which we'll look at in just a minute. Greenland melting has quadrupled since 2010. Meltwater coming off of Greenland represents about 1/4 of global mean sea level rise. And recent research says that the Greenland ice sheet, ice discharge into the ocean is far surpassing snow accumulation, and that the whole ice sheet is in a constant state of loss. Even if climate change stopped, the ice sheet would continue to lose mass, because the high elevation plateau of the Greenland ice sheet is lowering. And as it lowers in elevation, the probability of melting increases and the probability of snowfall decreases. The ice on Antarctica melt has tripled since 2010. It currently represents about 14% of global mean sea level rise, especially from this very dark area called the West Antarctic. There are a series of glaciers that flow out into the ocean, and they are buffered by these floating ice shelves. But warm water, as I mentioned, is being trapped underneath these ice shelves and is melting them from below, as well as warm air in the southern summertime is melting them from above. And the ratio of that melting is about half and half, 50% and 50%. These floating ice shelves are grounded, and landward of this grounding line where they are stuck on the bottom, the continent actually slopes back. And so once the floating ice shelves are freed from grounding, there's nothing to prevent all the upstream ice from flowing rapidly into the Southern Ocean. And two glaciers in particular, the Pine Island Glacier indicated by P and the Thwaites Glacier indicated by the T here, are flowing very rapidly, and they're showing new damage areas, especially if you look at P2 here, you can see these tensional fractures. As the ice pulls away from the bedrock walls that contain it, this is new deterioration of the ice that's being seen for the first time. In fact, a paper came out just last week. This is the Pine Island Glacier. It's color-coded for speed, and the movement of ice in 2009 was about 4 kilometers per year into the ocean, and it's now about 5 kilometers per year. And the author of this paper describes the Pine Island ice shelf as ripping itself apart. Again, it's these ice shelves that are buffering or preventing the continental ice from flowing catastrophically into the ocean. We have ice in the world's mountain systems as well, and all of these alpine glacier systems are losing mass. They are all melting, and combine all the mountain ice in the world, and it is showing a very strong retreat. It's losing 280 billion tons per year. That's actually equivalent to how much ice is being lost off of Greenland. So ice loss and thermal expansion of the ocean as it gets warmer are the two primary drivers of sea level rise. And you can see that the heat content of the ocean here is measured back as far as 1960, is rising and accelerating. And in fact, 2020 set a global record for ocean heat content. Thermal expansion of the ocean represents about 1/3 of sea level rise. And when you add these together, our physical models project that this century, we may see as much as 3 to 4 feet of sea level rise. That is if we do not get rapid West Antarctic ice sheet discharge into the ocean. If we do see ice shelf deterioration and Pine Island or Thwaites glaciers rapidly flow into the ocean, we could be open to multi-meter sea level rise late this century, on the order of 6 feet or above. That potential is very real, and the research is suggesting that the probability grows as we learn more and more. Projections also tell us that 2 centuries out, we're looking at on the order of 10 to 16 feet of sea level rise, again, if there is not catastrophic ice decay. Are we going to be successful at stopping global warming? Well, there's great news from the renewable energy sector. Renewable energy use is accelerating. You can see this histogram at the bottom from 2011 up to projected 2021 and 2022. Renewable energy additions to the global power production sector are growing. Renewable energy generation last year, despite the recession, grew by 45%. That's the fastest rate in 2 decades. 280 gigawatts were added to the world supply, which is equivalent to all of Germany's power needs. China accounted for 80% of new solar and onshore wind installations. And the projections for this year and next year are that renewable energy will account for 90% of new global power capacity. This momentum is likely to continue as long as lithium continues to be available. Nickel, cobalt, lithium, copper, rare earth metals, these are an important question. Do we continue to have access to these important minerals? The world, however, is on course to use ever more energy. And the current surge of renewables, while it is some cause for hope, it's really only a modest one. Carbon emissions are set to soar this year. the International Energy Agency projects global economic output this year to rebound more than 2% higher than 2019 levels. Demand for all forms of fossil fuels are set to grow. Coal demand is projected to increase by 60%. This is more than all renewables combined, just the coal demand. Emissions are projected to increase about 5% over this year. This reverses the 80% drop, or this reverses 80% of the drop in emissions last year in 2020. By the end of this year, the IEA projects that greenhouse gas emissions end up only 1.2% below 2019 emissions levels. And next year, there could be an even stronger rise as air travel returns. Emerging economies are driving the energy demand back above 2019 levels. Global energy-related CO2 emissions are heading for their second largest annual increase ever. And 940 million people still do not have access to electricity. They desperately need energy, and fossil fuels are often the only sources available to them. They deserve to have a higher quality of life. They deserve to have easy access to energy. This is one reason why I think it's critically important for the developed nations to strongly assist the developing world. We do this not only to help them, but to help ourselves. Recovery from the COVID recession has put the oil industry back in business. In the first quarter of 2021, Shell reported a profit, a $2 billion profit. Exxon posted a profit. BP posted a profit of $3.3 billion. Chevron. So the slowing of the oil industry was temporary, and they are coming back full bore. Now, let me end with some words about the natural world. Averaged between 2010 and 2019, 86% of our anthropogenic CO2 emissions came from combustion, and about 14% came from land use in the form of deforestation and agriculture processes which turn soil into a source of CO2 to the air. Of these sources, 46% go into the atmosphere and cause global warming. 31% are absorbed by photosynthesis, which we'll call the continental biome or the terrestrial biome. So a third of our CO2 emissions, and it's CO2 that's responsible for about 70% of anthropogenic global warming. So that's why we track CO2. Roughly 1/3 is taken up by photosynthesis on land, and the remaining 23% is absorbed into the ocean and causes ocean acidification. So this 1/3 of photosynthesis is a critical partner. Unfortunately, it looks like we are approaching a tipping point for photosynthesis. So plants use photosynthesis to remove CO2 from the air, but they also engage in what's known as respiration that releases CO2 to the air. Photosynthesis has a thermal maximum. Past that, photosynthesis sharply declines while respiration continues. Carbon uptake by land plants is already degrading. With continued emissions and continued global warming, carbon uptake is degraded, and it's projected to be reduced by 50% as early as 2040. This aspect of the natural world's losing its capacity to store carbon for us is not accounted for in any of our national policies, and it's not accounted for in the United Nations pledges to cut our emissions. An example of this is the Amazon basin. The Amazon contains more than half of all tropical rainforest. It lost 1/3 of its biomass last decade because of deforestation, drought, tree mortality, farming. And during last decade, the Amazon released 18 billion tons of carbon dioxide and absorbed only 15 billion tons of carbon dioxide. So we now feel that the Amazon is no longer a sink of carbon, it is actually a source of carbon dioxide. There's 6 emission sectors where we need to cut our greenhouse gas emissions. Electricity in general is responsible for 25% of emissions. Food, agriculture, various types of land use is responsible for 24%. Industrial processes, about 1/5. Transportation, roughly 14%. Buildings, 6%. And then other types of emissions, fugitive emissions and flaring, about 10%. And there are multiple pathways to take in each one of these sectors, depending on the specifics of the economy. Basically,
Chip, this is incredible.
I'm just about done, I promise.
Thank you.
This is our history of carbon dioxide emissions from 1850. And this is what we need to do with our carbon dioxide emissions by 2050. We need to reach zero emissions by 2050. And every single pathway for doing this that has been published requires negative emissions. That is, that we pull CO2 out of the air. And we have done absolutely nothing on the global stage, and also really nothing here on the local stage with regard to that, that sector of global warming solutions, sequestration. We have another 15 years if we target 2 degrees Celsius. Lastly, because sea level rise is inevitable for many generations, this idea of shoreline protection suggests that we need to stop erosion. We also have erosion prevention. If you stop erosion, you are going to kill beaches. We actually need to change our concepts here and allow erosion to happen. Because as you can see, many of our shorelines have sand deposits on the landward side of the shoreline that will be released by erosion and will allow a beach to migrate landward as sea level rises. Sea level rise is not the automatic death knell of a beach. Beaches can survive sea level rise, but we need to learn to get out of the way. And that is something that we still have a lot of work to do. Thank you very much, and I'm sorry I went over time.
That's quite all right, Chip. We could listen to you all day. I've got these other 4 panelists that I asked, we want to speak, and I'll let them get even with you. With that, Sam.
Mary, in the spirit of time, why don't we pass this on to the other speakers and then come back at the end and pick me up if we still have time.
Okay.
Yeah.
Okay.
Thank you.
So that means that we will have Bethany share her mana'o at this time. Bethany Morrison from Hawaii County.
Hey guys, okay, Sam, now I owe you one because I can't follow Chip's presentation very well. So let me share my screen and get started talking about what Hawaii County is trying to do to address these issues. Let's see. Okay, so, Chip outlined that we are up against some really serious issues. And so I just want to review Hawaii County and kind of the ways that we're thinking about trying to address some of this. We're a pretty unique island. We have a very diverse coastline. We have some beaches, but mostly rugged lava formations and steep cliffs. but overall, the size of our island, as you can tell, presents some challenges for us to try and manage some adaptation strategies for sea level rise and erosion of the shoreline. There was a report that came out for the state that looked at sea level rise vulnerability, and for the island of Hawaii, we only have passive flooding models available, but from that we were able to understand some of the impacts that we can expect. And we've also seen through king tides, which really demonstrate for us what the potential sea level rise would look like on a day-to-day basis. And so we're able to actually see that sea level rise in action through those king tide events. And then the Big Island also is sinking because of the weight of our volcano. And so that just adds to the impacts of sea level rise. We also have seen some significant storm events. We had Tropical Storm Isel, which produced some serious wave run-up and caused quite a bit of damage. I think they had 25-foot storm surges through that event. Hurricane Lane produced 52 inches of rain for some of our communities, and that caused several landslides around our Hamakua coast that have been chronic, but when they have the high rain events, they can, produce these large slides. So that's just some of the impacts that we're seeing from climate change, and more importantly, what are we trying to do to address these? So we're really focusing on the integrated approach to dealing with these. I'm a long-range planner, and so I'm really focusing on how do we get climate change to be part of all of our planning efforts. And so we have been supporting and partnering with local nonprofits who are doing great work on sea level rise studies. We have initiated a look at our shoreline and riparian setbacks. We are working to integrate our climate action planning efforts with both mitigation and adaptation strategies. We're in the process of updating our comprehensive general plan. And we also recently updated our multi-hazard mitigation plan. And both of those, general plan and the hazard mitigation plan, really focus on climate change for the first time. So a little bit more specific on what we're doing to address sea level rise. We are working as part of a nationwide cohort currently with ICLE. And again, we're working to integrate adaptation and mitigation into one planning effort. So this is a collaborative effort with our research and development and our planning department office. I'm working on the climate change adaptation planning piece. And this is just a little identification of our scope that we're working towards. Really, this came about through some recent conversations about how do we deal with these specific issues impacting our county assets. And so you can see the photo here that's really attempting to show us what one beach park might look like with pretty minimal sea level rise overlay. And so the conversation is really about, what adaptation strategies do we apply to these county assets? And just to give an example, this one, we had a grant that did the coastal hazard assessment to show the sea level rise vulnerability. But we're still looking for funding to do planning and adaptation strategies for this. But that's a pretty expensive undertaking for one beach park. And so through this climate change adaptation plan that we're getting started on, I really want this to address these priority assets and potential adaptation strategies on kind of a regional scale so that we can try and minimize our amount of effort that we spend on each individual asset, because we don't have the resources to really address it at that level. So that's what we're going to do with this first cut at the adaptation plan, is to identify those priority assets and system of interest based on some criteria that we're developing. And then from there, we'll identify climate threats, the risk and vulnerability assessment of those assets, and then develop some scenarios and adaptation strategies for those. So this is one of the projects that I'm currently getting started, and I'm very excited about it. The other thing we've been working towards is this multi-hazard approach, trying to recognize that if we overlay our hazards together, we can end up with some better decision-making and models. This was done in our multi-hazard mitigation plan update, where they suggested mitigation actions to address code and policy revisions for sea level rise, to make sure that we're looking at our shoreline change that might be happening when we look at our setbacks. And also, again, just that multi-hazard kind of an overlay approach to understand where we might want to make some different decisions as far as land use. Another piece that we have been working on through the general plan update is to look at, again, this multi-hazard approach. And so we had 3 products that we put together last year to start to get at some of those questions. One was a strategies report that looked at different ways to use land use to reallocate developments away from hazard areas. And then kind of as a partner to that was a GIS analysis to show what that might actually look like. And we used some multi-hazard risk assessments to analyze those different scenarios. So very interesting work came out of this approach. Was, again, looking at multi-hazards. So we developed strategy zones, which included kind of a high hazard area, moderate hazards, and low to no hazards. And so you can see here, the moderate hazards included kind of those coastal hazards with sea level rise. And then we also addressed an important concept for Hawaii County, which is our service condition. Knowing that we have a lot of underserved communities, we wanted to be able to map those according to the hazard overlays as well. And then we were able to stack the strategies to understand how effective they could be if applied. And so this map sort of shows you the strategy zones, with the red obviously being the highest of hazard areas, but also where a lot of our underserved communities are. And so again, this work was just to understand multi-hazard approach and how we could use land use to really make an impact, a positive impact. And one other project I wanted to mention is that we're starting work on having a research-based shoreline setback and also riparian setback. This work, as Chip has been working around the islands, you know, they have really addressed erosion of our beaches really well. But for Hawaii County, we don't have a lot of beaches, sandy beaches. And so we've had to really kind of look outside of the box and understanding different ways to look at that shoreline change that's still happening on our island, and also quantify that and make some recommendations. So this project is also just getting started. And one of the ways that we're really thinking about addressing this, because our island is so large and has such varying coastlines, is to come up with a coastal typology. And you can see a few listed here. And then building the foundational data and imagery around those typologies. And then being able to apply a specific methodology for each shoreline type. So for example, you know, for our sandy beaches, we could use the model that SOEST has been using to do the other erosion studies, but our cliffs might need a different methodology. So again, That work is ongoing, but it's exciting, and really just trying to look at ways that we can learn from the great research that's being done and make sure that we're applying it to our planning efforts so that we can make good decisions and build a better future. And with that, Mary, I think I'm done and can turn it over to the next speaker. Thank you.
Thank you very much, Bethany. And I forgot to make an announcement about questions. If you look at your list of participants, you'll see one of the participants' name is questions. So if you want to just put them into private chat to questions, then we did save some time at the end of the panelists to answer those questions. Thank you all for understanding and cooperating. Thank you. Go ahead, Tara.
Okay, before I get started, Sam, should I want to jump in and give you a chance if you want to interject. If not, I'm sure you'll have powerful comments to wrap us up at the end.
Yeah, go ahead, Tara.
Okay,
It's fine.
everyone can see my screen, yes? All right, well, aloha to everyone out there. I see lots of names I don't know, so it's really nice to have a new audience and appreciate your participation. I'm Tara Owens, and for those who might not know me, I am extension faculty for the University of Hawaii Sea Grant Program, specializing in coastal processes and coastal hazards. So in my extension role, I'm based here on the island of Maui, where I serve as a connector to the community and a partner to the county planners who, along with Sam and his staff at DLNR, are truly the front lines of coastal management. So today I'll provide a very brief overview of how sea level rise is affecting our coastal areas here on Maui and some of our responses to that. We have very diverse environmental conditions around Maui, although maybe not as diverse as the Big Island. Fortunately, there are many examples of relatively healthy, wide beaches with coastal dune systems. So the image you see here is a restored coastal dune system at Charlie Young Beach in South Maui, which provides a natural form of protection from coastal hazards. Of course, beaches and dunes are critical assets and resources that need to be protected and preserved. And as Chip pointed out, one way of doing that is getting out of the way if we can manage. Unfortunately, we also have many examples around Maui where development is threatened by erosion and waves. And the natural systems like the reefs and the beaches, wetlands and dunes have been altered or lost. So the image here shows a failed seawall in front of a condominium in Ma'alaya. The sign actually reads, "Danger, seawall is crumbling, do not climb on it." Looking to the future and resolving these issues, or maybe at least hopefully avoiding more of them, is part of our collective challenge in the planning process. And it's a big one. Erosion is widespread in Hawaii, as you already probably know, and especially on Maui. Maybe you're familiar with these statistics, but 70% of Hawaii shorelines are eroding over the long term. That's 85% on Maui. So compared to Oahu and Kauai, Maui's beaches are experiencing the highest rates of erosion, and Maui has the highest amount of beach loss. And our beaches in Hawaii also have high seasonal variability, which can increase risks when you're facing this sort of long-term chronic erosion. And it's all over Maui. So these images here just show you examples from all regions, West Maui, South Maui, and the North Shore, resulting from erosion, high wave impacts, all magnified by rising sea levels. As a really brief primer, erosion is caused by a combination of factors. So you already heard from Chip about sea level rise. That leads to this long-term chronic erosion process. Then you have seasonal wave conditions and storms, episodic erosion on top of that. And these are exacerbated by human impacts related mostly to shoreline armoring, seawalls and revetments. So by now, and this is where Sam was going to set me up, but I'm sure many of you are already familiar with the Hawaii Sea Level Rise Report and the companion viewer that goes with that. The viewer provides us property scale maps of potential future exposure to sea level rise. And the significance of that is that it provides a tangible basis for planning and policy discussions and decisions. Now, sea level rise affects us in several different ways. This includes two types of flooding: high tide flooding. You see on the top here, you see a screen grab from the viewer along with an actual photographic evidence of how that's occurring here on Maui. So two types of flooding: high tide flooding and high wave flooding, as well as land loss. It's a little different than the flooding issue, land loss from coastal erosion. And so we can look at the ways those impact our islands, and we may respond differently depending on, the source and the type of impacts expected in a particular area. Now, since the sea level rise viewer came into being at the end of 2017, it has quickly become part of household conversations, and it's now becoming institutionalized on Maui in some of the ways Bethany highlighted on a Big Island as well. So part of plans, policies, and decisions. Here in Maui, there was a County of Maui mayoral proclamation and a county council resolution in 2018 that directed all county departments to incorporate this information into plans and capital improvement decisions. So since then, it's now become part of the hazard mitigation plan. This information is being integrated into community plans that direct land use for the next 30 years. And it's also the basis for ongoing vulnerability assessments by the different departments in the county. So parks, Department of Environmental Management, water, and et cetera. Also becoming part of shoreline setback policy. So more on that in just a minute. Another project that's sort of a research to application project that's presently underway, and you may have seen a news release about this last week, is tailoring this information to the West Maui region. And if you know West Maui, it's an important coastal community, economic center, home to residents, historic sites, visitors. It also happens to be the hardest hit area on Maui and one of the highest in our state from the impacts of high water levels and waves and erosion. So in response to that, there was a need to develop more site-specific information to inform plans. So with a NOAA resilience grant, this effort involved a team of researchers from UH and PAC-IUS developing a localized wave model. You see that here on the left-hand side, which has been calibrated with on-the-ground photos of wave impacts that are collected by the community through a mobile phone app, and then turned into a forecast that you see here of upcoming wave impacts. So it's kind of like a 6-day weather forecast for waves. And we're currently working with our partner planning agencies to develop additional outputs that can be used for long-term planning. Finally, in terms of responding to coastal hazards and the issues we're facing, the options in the coastal management toolbox generally fall into the categories of protection, accommodation, ecosystem-based adaptation, and retreat. And at the extreme ends of the spectrum, you have protection or armoring. It has known consequences and is considered a solution of last resort. On the other end of the spectrum, doing nothing and letting things fall into the ocean is also not generally a desirable outcome. So the preferred strategies kind of become these ones in the middle, including things like accommodating by elevating and reconfiguring development, ecosystem-based adaptation, which can include dune, beach, wetland, and coral preservation or restoration, and managed retreat, which in our state is primarily happening in the form of setbacks. There's quite a bit of action all around Maui, so I have just some quick examples in terms of corals, beaches, and dunes, being our natural lines of defense against these impacts. The county has supported a long-standing and pretty successful dune restoration program that is currently managed by Sea Grant and volunteers. And that's one of our proactive strategies. There are also several proposed beach restoration projects on Maui that are in various stages of planning, including Kaanapali, Napili Bay, and Kahana. The example here shows a series of 12-story condominiums that are imminently threatened And in the one here, actually, there's a 5-foot sliver of land between the ocean and the building itself, and it gets flooded during high waves. All of these buildings were constructed in the 1970s before CZM regulations, so they were not subject to shoreline setbacks. The proposed solution in this case is a beach nourishment project to restore dry beach along the shoreline with 7 T-head groins as stabilizing structures. And this is the subject of a recent environmental impact statement published on the OEQC website. There are a range of benefits and impacts of a proposed project like this, and likewise, there are a range of community perspectives on this project. And finally, this is my last slide. One way to look ahead to the future, to try to hopefully avoid situations like Kahana, is through shoreline development setbacks. Maui was the first county in the state back in 2003 to adopt erosion-based setbacks. And now, armed with the information from the sea level rise viewer, the county is proposing to adopt new setbacks that would factor in future erosion with sea level rise. These setbacks would be intended to ensure, hopefully ensure, the safe siting of new coastal development and the protection of sensitive cultural and environmental resources. So in this image from the sea level rise viewer on the left and zoomed in on the right, the red line represents the projected erosion with 3.2 feet of sea level rise, which is our state planning target. The planners on Maui refer to this as the erosion hazard line, and they propose to require all new development or redevelopment to be sited landward of this line, plus an added 40 feet as a minimum future buffer. And so I'll leave you with an image of beauty and resilience, looking at a recently restored coastal dune at Kamaole 1 Beach Park with native pahuihui vines thriving on top of the dune. Mahalo.
Thank you very much. You got us back on schedule. Remember, go to the questions for questions in the chat box, and we'll now hear from Ruby from Kauai.
Hey everyone, just one moment. I'm glad to go after Tara. A lot of this will be similar but different. And I'm gonna make a quick switch here. Okay, so you just see the full slide now?
Yes, you did your edit. Thank you.
Okay. Okay, aloha everyone. My name is Ruby Papp and I work for the University of Hawaii Sea Grant College program like Tara. And I am a coastal land use extension specialist on Kauai, where I'm also seconded to the county planning department like Tara is. My role is essentially to act as a science advisor to many different county and community functions, particularly with regards to coastal hazards. And today I've got a short presentation on climate impacts on Kauai and some county efforts to address those. So like the rest of Hawaii, we are experiencing our fair share of coastal hazards, including coastal erosion, catastrophic rainfall, flooding, wave inundation, and our island has been the victim of 2 major hurricanes in the last 30 years, Hurricane Eva and Iniki, which caused billions of dollars in damage and paralyzed normal life on the island for years. And as Chip and others mentioned earlier, all of these hazards are exacerbated by climate change. I'd like to focus in, again, the same thing as others, on shoreline and beach erosion, as it's something we all deal with day to day and affects us in many ways. I know there's a lot of different terms that refer to erosion. This one, I just want to mention there is a difference between shoreline erosion and beach erosion, and I'll probably get corrected later. But shoreline erosion is a natural process, as is accretion or growth. But if there's human development in the way, that's different. So if there's no development in the way, the shoreline can typically retreat and bring the beach with it, depending on the backshore geology and all that. Beach erosion often occurs because we have a deficit in sand or hard structures in the way, and such as the road that is shown here in this image. On Kauai, based on Chip Fletcher et al.'s work, we know that 71% of Kauai's beaches are eroding, and 8% or 6 kilometers of beaches have been lost, or the lateral extent of beaches have been lost, all mostly due to the impacts of coastal armoring, which is designed to protect development on land from erosion, but causes beach loss, unfortunately. So I just would like to provide a couple of examples now. The first illustrating sea level rise and erosion's effect on critical infrastructure. So this is the Wailua Bridge and Kuhio Highway, our only access to the east and the north shores. So this is a screen grab of the sea level rise viewer map for Wailua, showing 3.2 feet of sea level rise, combined sea level rise exposure in blue, and then showing the different erosion scenarios in the colored lines, up to 3.2 feet in red. So for Wailua Beach, according to this, with just 1 foot of sea level rise, which is this orange line, and considered a near-term scenario, the erosion comes very close to undermining the highway and the bike path next to it. And just here are some photos from February of 2020, a relatively stable beach. The beach had been relatively stable for a few years until the winter of 2019, when we had frequent swells and anomalously high sea levels. So picture of what's to come. This started seriously eroding the beach. And so we have, oh yeah, so that red circle, notice that those are the rocks on the parking lot. Now we have them in the water here, significant retreat. And then by January of this year, we have the rocks way out here with some covering by sand, but then by March of this year, the parking lot was completely gone. And that's the highway right next to it. So some serious planning is needed, obviously, with critical infrastructure. This provides just an example of one of many roads that are located next to the shoreline. And we need to determine whether it's going to be relocated or needs to be protected. The current plans are to armor the highway by DOT, as I understand it. Another example is from Waipoli, also on the east side. This illustrates a typical problem with hotels, homes, or condos that are located too close to the shoreline. We're not quite as bad as Maui yet, but we're watching Maui very closely. This is what happened on the east side. And again, these places were, most of them were developed prior to modern shoreline setback regulations. These folks do have a temporary permit for sandbags, and they are pursuing a longer term option of beach nourishment combined with a groin to retain the sand, which may buy them a little bit of time. But again, these things do not last forever. And here's the sea level rise map with 3.2 feet of sea level rise, including the erosion lines. And you can see that much of this community is affected. And here's the hotel here, or condo hotel, I should say. So Tara had a similar slide. I guess mine's a little more blunt. Erosion responses for existing development are very limited, and most are temporary in nature. The only thing that really lasts is, you know, abandonment or relocation or managed retreat. As Tara mentioned, it's not a good idea to just do nothing, so that's not great. But it's quite, when we talk about the relocation option, again, quite challenging to achieve due to the myriad of social, financial, and legal reasons, which I'm sure many are familiar, and we probably will discuss in a minute. So the county, at the county level, much of the work has been focused on land use planning and regulations, such as robust shoreline setback regulations that incorporate sea level rise. It's much easier to influence future development than responding to existing development that's already in harm's way. Policies regarding existing development, such as managed retreat, or now being called strategic relocation, are a big challenge, but these discussions are absolutely necessary. So there will be more focus on climate action planning coming very soon. Before I get to that, just a little bit of history on what the county's done. The county updated its general plan, I believe in 2018, which I was involved with, and has some strong policies and actions to address climate change, including direction to plan for at least 3 feet of sea level rise and conduct vulnerability assessments in all low-lying coastal communities. And then incorporate those assessments into and adaptation strategies into plans and other regulations. So some good direction there. Following the adoption of the general plan, myself and other Sea Grant colleagues and UH colleagues in partnership with the county conducted a vulnerability assessment for West Kauai. And we used the sea level rise data, which was shown in the viewer, which Tara, I'm glad you teed that up for me. You explained the data pretty well. We used that to quantify all the exposed assets and properties and other resources that are exposed to sea level rise, and worked extensively with the West Kauai community through workshops to determine what's vulnerable, because exposure is a little different than vulnerability. And that helped us to determine some potential ways forward in terms of adaptation. Using the maps and data provided by the sea level rise viewer and the community workshops focused on what local citizens know about their own vulnerabilities to help further refine the data and to better understand the situation. And the workshops covered, and this is how all-encompassing this issue is. We had to cover transportation, drainage, critical infrastructure, cultural resources, beaches and coastal properties, and agriculture. And we probably didn't cover everything. Subsequently, we were pleased to see that some of the adaptation recommendations were incorporated in the county's West Kauai Community Plan, which was just recently adopted into the policies. And they adopted a new zoning overlay called the Special Treatment Coastal Edge for vulnerable properties. So this is an example of one of the community profiles we did for the town of Keikaha on the west side, utilizing the sea level rise data, but also the economic data that you can find on the sea level rise viewer. This shows quantified exposed buildings, as well as potential economic loss for that community. And the information, again, was used. The county then adopted an open coastal edge special treatment district, which will help to ensure that development in these types of vulnerable areas is carefully scrutinized and mitigated. So the county of Kauai is also thinking about other new and updated regulations to address sea level rise, including looking at expanding the boundary of the special management area permit system to cover the entire sea level rise exposure area. Currently a much smaller strip of land along the shoreline. And they're developing more specific rules for the Special Treatment Coastal Edge District in West Kauai. So lots going on there. But last but not least, again, the county is embarking on a more concentrated effort on climate change, the island-wide climate adaptation and resiliency plan, which is expected to start this summer, and which I believe and we hope will address a lot of the key issues and gaps regarding vulnerability of infrastructure, which hasn't really been addressed island-wide yet, and the managed retreat question. The plan will have hopefully a robust public dialogue on all the options, including managed retreat, hopefully providing a good venue to make these tough decisions that everyone's alluding to. So that starts this summer. And I will end there. Thank you so much for having me today, and I look forward to the discussion.
Sam, would you like 5 minutes?
Maybe we just want to move to questions at this point. I really people come to these events wanting to, pry us with questions, and I think we should give them that opportunity. So
I think there's actually one that might be a really good question for you.
Okay.
That was, could the panel please clarify the difference between adaptation versus mitigation?
Sure. I can make a short attempt at that. Our office actually houses the State of Hawaii Climate Change Mitigation and Adaptation Commission. And so we have to know what mitigation means, and we have to know what adaptation means, because they're not necessarily the same thing. Mitigation involves steps to reduce greenhouse gas emissions, steps to remove carbon emissions from the atmosphere, if we can do that. Steps to reduce your carbon footprint, right? Driving electric vehicles, using renewable energy, engaging in farming practices that are sustainable, don't eat as much meat. All of those kind of things are sort of under the rubric of mitigation. That's the Paris Accord. Adaptation is things that we have to do to reduce the inevitable changes that are coming with respect to the impacts of climate change and sea level rise, i.e. everything that Tara and Bethany and Ruby talked about today are types of adaptation measures we need to take in order to reduce the effects of sea level rise on our communities. We can never stop it, as Chip said. All we can do is manage it better than we would have if we had done nothing. That's my take on it anyway.
Okay. So the voice behind our title questions was Mahina. Mahina, would you like to bring forward any other questions that have been asked?
Sure. A mahalo to everyone here and for the panelists. I learned so much. I have just a couple questions that were sent in. The first one is, can we sponsor a bill to give tax credits to coastal homeowners to encourage them to elevate their homes? I don't know if anybody wants to take a first crack at that one.
Chip,
Well,
go ahead, Sam.
That's an interesting thing, giving tax credits. It's like, and please don't take this the wrong way, whoever's listening, but it's like, giving tax credits to people that buy EVs. Well, yeah, it's a fantastic way to sell EVs, but in some ways it's simply a benefit to the rich people, that we all end up having to pay the bill on that. And I think we would look at it the same way with, coastal property generally, and this isn't always the case, and I'm not typecasting, the people that own coastal property generally have resources, and, should we be using taxes, or should we giving up tax funds that could be used for adaptation measures by giving these people tax breaks? I don't know. That's a policy call at a very high level.
Go ahead, Chip.
I put a note in the chat that the National Flood Insurance Program already requires us to build above the 100-year floodplain, but Congress controls what the National Flood Insurance Program can and cannot do, and Congress has not yet embraced climate change as an issue worth acting on. So what I've heard several communities doing is adding a foot or 2 or 3 on the National Flood Insurance requirements. So that is one way to just get elevated above the 100-year floodplain that could take into account some elements of sea level rise and enhanced rainfall. So I don't believe Hawaii has added freeboard on the NFIP, and that's something to consider. I think Tara had a comment.
Go ahead, Tara.
Thanks. I just wanted to add to both of you. Actually, yes, Maui has a 1-foot freeboard on our flood regulations. But I also wanted to add that if some kind of legislation were pursued to promote elevating structures, and elevating obviously is a very good idea in some areas, and we still do so much slab on grade construction along the shoreline. But I always like to point out to my community members that elevation can work really well if it's a flooding issue, but if it's a coastal erosion issue and you're losing land, then elevation, may not be a good adaptation tool. So we have to look at those nuances as well.
Any other questions, Mahina?
Yes, actually, we have a few more coming in. And while we're on the topic, so there's a couple of technical questions and then perhaps one more like theoretical for Chip. We have somebody asking for you to talk a little bit about talk more about your thoughts about embracing erosion. Maybe taking us through, like, is that in reference to shoreline erosion versus upland erosion of organic and mineral soils? Or if you can just like talk a little bit more about your thoughts there.
Yeah, we don't have much time, and frankly, I don't have a solution to this problem. There is a report that the Coastal Zone Management Program published in 2018 or 2019 on strategic retreat from the shoreline. It is more of a high-level review of the problem. It doesn't propose a strong menu of actions to take. I think there needs to be a very strong, focused effort by planners and economists and scientists and representatives of the various constituencies in the coastal zone to figure out how are we going to get out of the way of rising sea level on those beaches that we want to be sure are here for our grandchildren, which Sam's shop and a whole crew of us over the years have taken to calling legacy beaches. What is the legacy we're going to leave behind on our shoreline? Is it going to be a legacy of seawalls and beach loss, or is it going to be a legacy of preserved beaches, probably in the form of more beach parks? How are we going to do that? What is the exit strategy for single-family homeowners and other human assets that are threatened by erosion that we do not want to harden?
Great response. Thank you.
Thank you. I have another question for Sam. So Sam, does the shoreline certification process need to be overhauled to address a potentially rapidly changing situation? What are your thoughts on that?
You're muted, Sam.
That's sort of, in my judgment, a minor thing, really, in light of everything else that's going on, and the longer term threat from SLR. Right now, the shoreline obviously process is the outermost extent of the wash of the waves. If you want to get anything more out of that, we've got to start using projections of shoreline location in the future, or just projections of inundation areas in the future, and beginning to use these types of data sets as benchmarks for development or controlling development. But the certification process right now is, I don't think it's the proper vehicle in which to address that issue. It needs to be addressed on a broad planning scale, not on a property by property basis.
Mahalo, Sam. Would anybody else like to comment on that, or should I move on to the next question? Oh, okay. Okay, we have a question about, why is Maui affected more than the other islands?
Okay, I think this question goes back to the statistics I gave about Maui having higher rates of erosion and beach loss. And actually, this would apply also to the Big Island. It has to do with island subsidence. So sea levels rising for all of us around the islands, but then the Big Island and Maui also have this issue with island sinking because of the Big Island's constant growth and settlement on the flexible lithosphere.
Okay, thank you, Tara. I have one more question, asking if any of the panelists have comments on the rebuilding of the seawall between the aquarium and the Kapahulu area in Waikiki.
Well, that was a permit that we issued. Maybe I should say something about that. So what are our thoughts about that? I would have preferred personally that they would abandon continued wall repairs or repairs to the promenade in that area of Waikiki fronting Kapiolani Park. That would be my personal preference. For legal reasons, we were kind of roped into giving them an authorization to repair what they had. We had a beautiful concept plan at one point that we could scallop some beaches into Kapiolani Park there. Scalloping meaning, you know, dig out the land, similar to what you'd see at Kualina, the Old West Beach Resort. And unfortunately, I met quite a bit of resistance to that idea. In fact, got thrown out of the mayor's office at one point for suggesting that we do that. And the comment coming back to me was, "Oh, how would you feel if we tore down the state capitol?" I'm like, okay, I get it. But we do need to really think seriously about getting out of the way, as all the speakers have said, because the longer we stay, the harder the impact is going to be, right? The more it's going to cost us, the more grief, the more pain, the more complexity, the more political and legal strife. People really need to think futuristically at this point. I mean, we have the science telling us or predicting what's going to happen. That's a rare opportunity for people. People don't usually have an opportunity to see the future, to look in the crystal ball, to understand what's going to unfold. It's a rare opportunity for us to take that seriously and take action now to change the course we're on. It doesn't seem like we're doing it on a global level or a local level even, although on a local level, I will say that I am overwhelmingly impressed by what's happening in the Hawaiian Islands, the level of interest, the level of science, the level of planning that's going into solving this problem is unprecedented, perhaps in the United States, to the point where, you know, Chip and I were there at the beginning and I don't even know what the hell's going on half the time. And that really makes me happy because, you know, I see other people taking the baton, which is what has to happen if you really want to have long-term enduring change in our society. So it's really a beautiful thing to see. On the broader scale, I think we're missing the bus on greenhouse gas emissions, because it's not necessarily about recycling. It's not necessarily about electric cars. It's not necessarily about you know, these things that I call shallow ecology. It's about dealing with population, dealing with conspicuous consumption, fundamentally changing the way we do things in this planet so that we can reduce our presence, reduce our carbon footprint. Only then will we be able to make adjustments, or will the system adjust or equilibrate in a way that makes it more habitable. If we don't go there, it's going to become uninhabitable at some point for humans. It is going to be a planet of the apes. Charlton Heston on the beach, pulling his hair out, screaming, "Why did we do this to ourselves?" I mean, that's the future I foresee based on what I'm seeing. Not locally. Locally, we're all doing the best we can. You know, bless everybody's heart. But on a global level, we have some serious challenges and some serious reckoning to make with things if we really want to get this ship going in the right direction. So that's all. That's really what I wanted to say today. And thank you for the opportunity for having said it.
Well, I think that was a perfect segue to closing up this presentation. Thank you all for attending. The fact that all of you came on your lunch break like this is just shows that you all care, and we really, really appreciate knowing that. The Environmental Council of the Office of Environmental Quality Control is wanting to get more and more information, get more of the citizenry involved so that it's not Sam and Chip and now Ruby, Bethany, and Tara. In wrapping this up, I'd like to say thank you to our panelists. Thank you to all of to the council for allowing the Information and Outreach Committee to work on these forums. Our next forum is currently scheduled for July 21st. That one, the topic is watershed protection and better stormwater protection. So look for more information on that. And I'm going to turn this over for a really quick second to the most hardworking volunteer in the whole wide world, our chair, Onana Thome. Onana?
Thanks so much, Karen. Thank you so much. Thank you again, everybody, for joining us for the first forum in this series. As Mary mentioned, we're going to have many more. All of the panelists, you are wonderful, and we really appreciate you folks taking the time to do this for us. And I also want to thank again the Information and Outreach Committee. I mean, they took this on and really put everything together. And so that's Mary Bejer, Don Heger Nordblum, and Roy. Where's Roy? Is Roy here today? Roy and Mahina Tudor. Okay, I'm not sure if Roy was able to join us, but in any event, we really do appreciate.
Picture up, but he's there.
Okay, all right, Roy Abe. So those are our 4 Information and Outreach Committee members. If you folks have any follow-up questions, please feel free to reach out to us afterwards. And we really do hope that we see you at our future forum. So thanks again, everybody.
Thank you, panelists. You were fabulous.